So we're looking at example 4 in our notes for direct variation. And number 4 is an example of an application. So this application says the number of pages a student can read, P, so P is the number of pages, varies directly with the amount of time spent reading, which is T. So P varies directly with T tells us that P is equal to the constant of variation times T, where T is the time in minutes and P is the number of pages. The student can read 90 pages in 60 minutes. So we put in a 90 for P and the T is 60, right? That would be an ordered pair on this line. So our constant of variation M is P divided by T. P is 90 pages. T is 60 minutes. And 90 divided by 60 reduces to 3/2. So that's the constant of variation that goes into our direct variation equation as the M. So our equation for the direct variation is P equal to 3/2 T. Right? That's the equation that relates P and T. Next, we're asked to use this direct variation equation to predict the number of pages the student can read in 90 minutes. 90 minutes is the time. So the number of pages that can be read in 90 minutes, we would substitute 90 for the T. And then 2 goes into 90 45 times. And 3 times 45 is 135 pages. Okay, go ahead and pause the video and give this problem a try. The weight of an object on Mars, M, varies directly with its weight on Earth, E. An object that weighs 70 pounds on Mars weighs 210 pounds on Earth. If an object weighs 160 pounds on Earth, how much would it weigh on Mars? When you're ready to go over the answer together, you can resume the video. So, M varies directly with E. We were told that the weight of the object on Mars varies directly with its weight on Earth. Okay, then we're going to use our numbers that are given here, that an object weighs 70 pounds on Mars and 210 pounds on Earth. We're going to use that to find the constant of variation. And so our constant of variation, M divided by E, 70 divided by 210 is 1/3. Okay, then we can write our direct variation equation. M is equal to 1/3 E. And finally, if an object weighs 160 pounds on Earth, how much would it weigh on Mars? We're going to put that 160 into the equation, substituting in place of E. So the weight of the object on Mars is equal to 1/3, the constant of variation, times the number of pounds the object weighs on Earth. And 1/3 of 160 is approximately 53.3 pounds.